How can neuropsychoanalysis help us to understand artificial intelligence? We encounter artificial intelligence every day, which is modeled to a certain extent on human consciousness. And so, AI gives us a view into what we know and what we may not know about ourselves. In addition, we now develop our sense of self and others both within the virtual and material worlds. AI could be said, therefore, to not only be modeled on human consciousness, but it is also impacting our development directly. In this podcast episode, Dr. Rosa Spagnolo discusses consciousness, artificial intelligence, and the development of superintelligent AI. She considers what this implies for human and AI development, identifications, subjectivity and suffering, leveraging neuropsychoanalytic understandings of the mind. Dr. Rosa Spagnolo is a child neuropsychiatrist, developmental psychotherapist, and psychoanalyst member of the Italian Psychoanalytic Society and the International Psychoanalytic Association. She's co-chair and co-founder of the Italian Psychoanalytic Dialogues Association. Dr. Spagnolo is a member, regional coordinator, and chair of the Italian group of the International Neuropsychoanalysis Society. She teaches at several institutions and is a sought-after speaker at the national and international conferences. She's written several books and articles on a variety of topics, including eating disorders, group psychoanalytic psychotherapy, neuropsychoanalysis, and neuropsychiatric developmental disorders. She was nominated for the Gradiva Award in 2019. I'm Nicole Zapian with Talks on Psychoanalysis, the International Psychoanalytical Association's podcast devoted to topics published in the IPA Society journals and Congress debates worldwide, featuring the original voices of the authors. This podcast series, published by the International Psychoanalytical Association, is one of the activities of the IPA's Communications Committee and is produced by the IPA podcast editorial team, led by Gaetano Pellegrini. Editing and post-production are managed by Massimiliano Guerrieri. To stay informed about the latest podcast releases, please sign up today.
Artificial intelligence and psychoanalysis meeting the future. The advent of artificial intelligence systems, different from the biotypes known so far, has opened up a vast front of debate that involves all scientific communities. The questions raised concern both their use and their evolution towards the formation of agents endowed with an intelligent mind. It is an encounter with the future that we will try to approach. This podcast will be divided into 3 parts. A first part concerns the relationship with virtual reality. A second part summarizes artificial intelligence systems. In the third part, we will consider the questions proposed by the scientific community on artificial consciousness. Part 1. What identification with cyberspace? The comparison with the generation born after the 80s passes through the digital revolution that introduced new forms of communication and learning, otherwise unthinkable for previous generations. These new virtual realities allow simultaneous interaction with many other subjects in the total absence of the limits that the body imposes on embodiment. The relational multiplicity of online, which has a strong impact on offline life as well, forces us to rethink the meaning assumed by the term identification within the relationships reshaped and redefined by virtual space. For digital natives who have grown up from their earliest years among mobile phone, robotic toy, and video games commanded with only iconic signals, usable even without being able to read, the virtual world cannot be considered as something parallel to the reality of objects, which stands beside the material reality and hence multiplies the real self and real objects in a dimension other than material reality. For digital natives, virtuality is embedded in everyday life. It's part of it as an extension of the self to the world in a mutual and constant co-construction. The relationship built within and through cyberspace are thus part of their spontaneous processes of self-other world identification, of which virtuality is one of the many features of interaction. Digital natives are individuals who can easily take advantage of virtuality and relate to it as if it were a material object. In this sense of real virtual, the self-other front widens to include the world, with self-other world boundaries not always easily distinguishable. The self is immersed in this reality, material, virtual, mixed. It's permeated and forged by it continuously. It's an extended self-other with a window always open, always on generation on the world community. Through the constant use of technology, which speeds up all the steps to reach the other, the individual is public, easily identifiable by one or more ID. Through our ID, we are virtual and material at the same time. However, we are already immersed in the AI to which we provide the data that we continuously update through the use of technology. If this continuous public exposure renders the notions of privacy and authenticity obsolete, what path does identification take in the construction of one's subjectivity? The constant link with the other, echoed and cheered by the always on, the many contacts that form a dense network of horizontal relationships, the interweaving around countless profiles of infinite possible narratives. All this creates new identifying bonds that are the subject of new thoughts for us analysts. The massive use of online, both in terms of communication, Zoom platforms, Skype, Google Meet, and exchange via social networks like AI or Metaverse, forces us to reconsider the concepts of inside-outside, presence-absence, subject-object, and especially that of singularity-multiplicity. Virtuality is thus increasingly configured as a story written by many hands, in which the blurring of boundaries between real life and the virtual reality continues to amplify our potential to control the self-other world by thinning its boundaries, but above all, by eroding its subjectivity. Part 2. What are we dealing with? A terminological premise. AI means artificial intelligence. AA, artificial agent. VR, virtual reality. AR, augmented reality. MR, mixed reality. All of these are different acronyms that all indicate in different ways the development of digital agents in social contexts. There are technologies that improve the control of the environmental context or, like VR, AR, and MR, founders of the metaverse, also called extended reality XR, are able to stimulate the various human senses, thus enable a perception called sense of immersion. Immersive technology is defined as technology that blurs the boundary between the physical, virtual, and simulated world, creating a sense of immersion, growth. In order for a true metaverse to emerge, future innovations in machine learning, thus in the development of artificial intelligence and data analysis, will be crucial. At present, while combining AI and XR and developing immersive virtual realities even closer to the human mind, the former does not have the complexity of the latter: symbolic representational capacity, stochastic responses, multiple and random interactions, emotional complexity, and thus the proposed immersive reality risks generating symbolic simplifications and impoverishing the complexity of the human psyche by reducing it to a simple computational operation. Neuroscience plays a key role in the development and design of artificial intelligence, and is trying to go beyond computational functionalism. This research concerns both the project of artificial intelligence systems that emulate human intelligence and the construction of artificial neural networks that help us better understand how the brain works. What is artificial intelligence? Artificial intelligence is a machine-displayed intelligence that simulates human behavior or thinking, and by combining machine learning and deep learning techniques can be trained to solve specific problems. Typically, various artificial intelligence models are trained using a large volume of data and, depending on the model, algorithm, and training used, have the ability to make decisions. The development of artificial intelligence systems has brought together neuroscience and several engineering disciplines, producing the current revolution in modern artificial intelligence, based on the design and the construction of deeper neural networks. Processing systems with individual artificial neurons connected in a hierarchical, distributed network through goal-directed training tasks. The field of AI now also seeks to make sense of how information is processed in artificial neural systems to produce a mind. But what exactly is artificial intelligence and how does it work? Even without being aware of it, and without going into technicalities, we interact with artificial intelligence on a daily basis. From smartphones to chatbots, from interactive TV to data searches, from gaming to video games, artificial intelligence is already prevalent in many aspects of our life. For example, we use so-called reactive machines on a daily basis that do not have the ability to form memories or use past experiences to make decisions. These machines are designed to perform specific tasks. Some of them are equipped with low memory chips, and they can use this memory to repeat the program without creating new ideas. Amazon Echo or Siri are the simplest of the AI currently on the market. Amazon Echo is a smart speaker that uses Alexa, the AI-enabled virtual assistant developed by Amazon. Amazon Alexa is able to interact vocally, play music, set alarm clocks, play audiobooks, and provide real-time information such as news, weather, sports, and traffic. The data it collects is not directly available to the user as an extended personal memory, but acts as a data collector to implement the system and make this new data, our data, available in continuous updates. Interacting with a talking machine is not the same as being in the presence of any intelligent being. The machines, AI agents, that cause perplexity in their use and the further development are those that are interactive, using verbal language or other languages encoded to simulate human experience, implemented by the capacity for unlimited associative learning. Particularly, there are two A that give rise to wide reflection in the scientific and political worlds. Those endowed with theory of mind and those endowed with self-awareness. The former can recognize others, socialize, understand the human emotion, move in different environmental conditions, what degree of autonomy is being studied. The latter, those endowed with self-awareness, animate the scientific debate on what is the minimum unit, agency, endowed with this type of awareness, and what is the evolution of the relationship between AI machines and mankind. These super intelligent, possibly sentient and conscious machines, capable of reacting very much like a human being, are the machine of the not so distant future. The current ones, machine learning and deep learning, already have the ability to learn. The former using algorithms to generate insights from the data they are exposed to. The latter through the ability to mimic the human brain's neural network. Super intelligent machines, perhaps sentient, perhaps endowed with consciousness, pose relevant ethical issues to the community. Part 3. AI and the human mind. There are many things that humans perform with ease that computers cannot do, such as understanding spoken language in its entirety, semantics and proxemics, and abstracting its intentionality, performing object recognition by exploring it visually or by touch, and integrating the sensory information, navigating with the mind in the present or in the past, and fantasizing about the future. These are easy tasks for humans. Despite decades of research, there are few good algorithms to achieve this performance from a computer, Lindsay wrote. But the opposite is also true. There are many things that computers can do that individuals, human mind cannot. For example, processing complex computations in a few seconds. The recent resurgence of artificial neural network models in computational neuroscience has refreshed the idea of correspondence between synthetic neural models and real neural activity. This correspondence has been demonstrated in the visual cortex of primates, where artificial neural networks trained for object recognition have been able to predict real neural activity. This same approach has been fruitfully applied to capture neural response properties in many other brain areas, including auditory and motor areas. AI research certainly sheds light on the workings of the brain and the human mind and captures many fears. Metzinger speaks of artificial suicide and proposes arguments for a global moratorium on synthetic phenomenology until 2050. Such a moratorium would have the sense of limiting the emergence of an artificial consciousness in post-biotic machines until we have valid ethical criteria for understanding what he calls negative synthetic phenomenology. That's, in a nutshell, if there is a phenomenological consciousness in an artificial sentient being, the problem of suffering arises. Many philosophers and neuroscientists question the intelligence consciousness equation. Does one entail the other? And to what extent? Would creating intelligent machines mean creating sentient and conscious beings, humanoid seen through the principle of pathocentrism that leads us to take a moral stance? Does our anthropocentric point of view really grasp the reality of artificial consciousness, which could be something totally different from the human mind? Or does it merely equate it with the brain functioning that we assume generates consciousness and self-representation? Undoubtedly, the dialogue sparked by the call for a moratorium has amplified both the debate around models of consciousness and the debate on the indicators of synthetic consciousness, which would constrain the creation of thinking machines and thus of the use of AI. Surely, all disciplines involved in the AI, sentient mind, artificial consciousness dialogue agree that the human mind is more complex than any algorithm currently being developed, and AI design will have to address at least the following points in order to meet this challenge. The organization of human memory. Will artificial neural circuits be able to take into account, for example, the hierarchy of the maturation of memory systems, such as the maturity of the hippocampus in the first 3 years of life, with the prevalence of perceptual and emotional circuits already active in the first year? Highlight. This immaturity guides the future development of episodic memories and at the same time creates the emotional imprinting through which the memory systems will interact throughout life. The relationship between conscious and unconscious, with the different degrees of awareness and automaticisms, which allows us to go beyond the narrative and organize defenses and structure that would otherwise only be on the descriptive order. Or again, how to deal with the knot of primary and secondary identifications constitutive of one's subjectivity and its transmission as otherness. Without such a knot, every artificial being would be identical to the other or to itself, depending on who designs it, without any future variance. Also, if these intelligent machines survive humans, this would raise the questions of their very persistence beyond the finiteness of human existence. And finally, agency, namely the marker of self-awareness, which means facing affects, suffering, responsibility for act, the ethical and moral responsibility. As stated above, AI is not the brain, and synthetic consciousness is not a biotype. In other words, being in front of wetware, biological material, or hardware, physical material, being in front of a neural network or in front of a set of silicon gates makes a difference. Therefore, in defining sentient being and the emergence of consciousness, it's not only what the system does, how it processes information that matters, but also the biological substrate to which it belongs. Discussions on the degree of consciousness and awareness in the animal kingdom have taught us not to attribute these functions to anything that responds to a stimulus, learns something, and maximizes rewards to achieve a goal, Anil said. The advent of brain organoids, the mini brains grown in the lab from stem cells, should perhaps pose more problems of ethical prevention than AI and virtual reality do. Between panpsychism, consciousness is everywhere, and eliminativist materialism, consciousness does not exist. There is a wide range of options with which we are confronted and whose future scope is under scrutiny by scientists. For our part, we can only continue to emphasize that we can perceive, react, and relate to the world because it is part of us and we are part of it with, through, and because of our bodies. Anil said, the Copernican revolution gave us the universe, the Darwinian revolution the family of the animal kingdom. Einstein gave us time, Freud the depth of the human mind. What will we encounter in the future of the virtual? Perhaps a new revolution is underway, the displacement of the mind in an alias that persists beyond the finiteness of the biological body. It's an uncanny encounter with the future because we are already sentient virtual beings in a virtual world, but still endowed with a body vulnerable, which for this vulnerability, Damasio wrote, requires a sensory motor apparatus that control its homeostasis, adaptation, and survival. A post-biotic system, not resting on this vulnerability, what kind of intelligence will it be able to express?